Welcome back to Neuron Short 5 about the Protect range. The Protect cards are specifically developed to safeguard and guarantee incoming and outgoing signals. There are currently two versions available: the PFG 1616, which stands for Protect, Firewall, Gateway with 16 IP input streams and 16 IP output streams, and the PXG 1616, which stands for Protect, Cross Connection Gateway, which also has 16 IP output and 16 IP input streams. Let's start with the easier one, the PFG 1616, which is a straightforward full IP isolation firewall. This card ensures 100% safe signals entering and leaving your facility. The IP input streams are depacketized so that only the raw baseband video, audio and metadata is entering the processing paths. These aren't IP signals anymore, so any possibly harmful or hostile internet traffic is simply thrown away. After processing, the media signals are packetized in fresh new IP packets and streamed out over the other QSFP port, ensuring that there's no direct link possible between the incoming IP streams and the outgoing IP streams. You can see it as the customs check when you want to deliver a videotape to a demilitarized zone. You hand over the box to the customs officer, who unpacks everything, strips all the unnecessary contents and packaging material and puts the tape in a new box. That new box is then taken into the DMZ by an internal courier. That's what the PFG does. Looking at the UI in Cerebrum reveals that the PFG has 32 Full HD processing paths, 16 paths with audio de-embedders intended to be receiving signals, and 16 paths with audio embedders intended for sending signals. So the PFG simultaneously secures 16 Full HD inputs as well as 16 Full HD outputs. All paths have frame sinks and video delay as well as color correctors. The paths with embedders can also do audio gain and phase per audio channel. This looks very similar to the BSG 1616 bridge card that we've talked about in Neuron Short number 3, but with the difference that with the PFG there's no SDI I/O possible and that the Ethernet inputs and outputs are crossed. So everything that is received by QSFP1 streams out on QSFP2, and what is received by QSFP2 streams out over QSFP1. So the PFG is the perfect card for safeguarding interconnections between venues, where the signals entering a facility need to be 100% safe and secure. So every broadcast environment that is receiving ST2022 or 2110 streams from the outside world needs at least one of these cards. The PXG 1616 is similar to the PFG 1616 with regards to the full IP isolation firewall, but with the addition of also performing integrity checking on the incoming video and audio. In the SDI world, every broadcast environment relied on integrity checking probes to constantly check for video presence, video freeze, black video, audio channel availability, audio formats, audio silence, etc. Whenever the video or the audio didn't pass the checks, the probe would switch to a backup input to always ensure a valid AV output. In IP, most broadcasters rely only on ST2022-7 for redundancy, as explained in Neuron Short number 3. But -7 only checks for bad packages to switch to the redundant signal. It does not check the video and the audio quality that is inside the packages. So when, for instance, your video freezes but the packets are still okay, a -7 input sees it as a valid feed and will simply pass that frozen video. No alarms go off and no one will be notified about it, and there's no device that switches to a backup input. Also, a single device with -7 compatible inputs still is a single point of failure. If that input or that device is powered down or stops functioning, you're left with nothing, even though you have a fully redundant separated red and blue network infrastructure in front of it. The PXG prevents both these risks. It continuously checks for video and audio issues, as well as signal integrity, and when you have two PXG 1616s interconnected with each other through the dedicated TDM connection using the SFP Plus I/O, visualized in this drawing, it also solves the -7 single point of failure I just explained, with the top PXG connected to the red network and the bottom one seated in another frame, to the blue network. When, for instance, the top PXG detects an error in the video or audio, or when the red local switch breaks down, it can switch to the backup inputs coming from the bottom PXG, which also continuously checks the signal integrity of the backup inputs. The cards communicate with each other, informing the validity of each of their input signals, so that both cards can decide per processing path whether they should use the main or the backup input. And even when one of the PXGs is powered down, you'd still have your blue network feeds intact from the other PXG, so there's no single point of failure anymore. We published a white paper on our website explaining how to overcome the flaws of the -7 redundancy concept in more details using the PXG 1616. You can check it on evs.com under Resources, White Papers, Redundancy in Live IP Media Infrastructures. Let's have a look at the interface of the PXG in Cerebrum. You can immediately see the differences compared to the bridge and the convert cards. The PXG has these probes in front of each processing path. If you click it, this pop-up will appear. In this window, you can set per detection criteria whether you want to only probe for errors and be notified when an error occurs, or if you want to switch to a backup input coming from the other PXG. So you can decide per path under which conditions it should switch to the backup input or not. Below these settings you can see the video and audio status of the main PXG and the backup PXG of this particular processing path. You can even further refine the freeze and black detection settings, where you can set a region of interest and the threshold when a still video image is detected as an actual video freeze. Again, this can be set per path. In the Audio Probe Status tab, you can see the status of each embedded audio pair, and you can set the detection conditions for these pairs individually. If we close this pop-up, you can see by the color of these switch icons and the color of the arrow at the end of each path whether this path is switched to the input of the backup PXG or not. When it is switched, the icon is colored green and the arrow at the end of the path is yellow. What you can also see in the Video Paths tab is that the PXG can do up-down cross conversion, just like the convert range, but without the HDR conversion capabilities, and that it can be equipped with the SDI expansion board to also perform SDI to IP and IP to SDI bridging. Another extra feature you get with the PXG is the auxiliary data insertion and transparency, of which you can find the settings here in the audio and ANC data embedding pop-up of each path. The PXG has a unique probe tab, giving you an overview of the detection settings of all processing paths in one view, with access to each path's individual detection threshold and region of interest settings, and below that you can see a complete overview of the video and audio statuses of each path, to easily spot errors in video or audio at a glance. The other tabs, like the IP Video I/O and Audio I/O tabs, are similar to what you're used to in the bridge and convert cards, with the only difference being that, just as with the PFG, the I/O of the PXG are crossed. As you can see, the PFG and especially the PXG are very powerful and flexible quality assurance Neuron products. They will significantly reduce the mean time between failures of an entire broadcast facility, ensuring valid, safe and fully isolated signals on all sources and destinations in your IP domain. Once the cards are configured according to the defined fallback scenarios of the facility, you have reliable 24/7 real-time IP media integrity checkers constantly checking the video and audio without single points of failure. And when any of the set parameters fail, it can automatically switch to another feed and immediately alarm end users about the error. The PXG becomes especially versatile in combination with Cerebrum. Any of the status parameters on the video status and audio status tabs can be the trigger for any other device in the facility to automatically change its settings. For instance, In one integrity checker on one of the paths, a video freeze is detected, triggering a multiviewer to highlight that feed with a giant red border, triggering lighting equipment in the MCR to flash red, automatically switch all destinations of that source in the router, and send a text message to the head of engineering. Remember that the Protect cards are also using the same hardware as any other Neuron products, meaning you can always reprogram your processing boards at a later stage to change the functionality entirely by programming a different software version. So you can, for instance, reprogram your bridge on Convert to be a PXG when needed. And that's the Protect line of Neuron. The next Neuron short will be about the compress range. Thank you for watching again.